There are roughly 40 million perfectly functional scanners sitting in closets and landfills right now, dead not because they broke, but because Windows 11 refuses to speak to them. Here's how engineers made a web browser run an entire operating system just to resurrect a scanner from 2003. The problem is absurdly simple. Your scanner works. The motor spins, the light bar moves, the CCD sensor reads just fine. But somewhere around 2015, the manufacturer stopped updating the driver software. Windows 10 dropped 32-bit driver support. Apple moved to ARM chips. Linux updated its kernel. And suddenly, a $400 piece of precision hardware became a paperweight, not because of hardware failure, but because of a missing software handshake. This happens to millions of devices every year. Printers, scanners, MIDI keyboards, oscilloscopes, anything with a USB port and a driver CD from the early 2000s. The hardware is immortal. The software ecosystem moves on. And we throw away perfectly good machines because nobody wants to maintain a Windows XP virtual machine just to scan a document. But here's the thing. Web browsers are now more powerful than most desktop operating systems were in 2003. Chrome, Firefox, and Edge can compile C code to WebAssembly and run it at near-native speed. They can access your camera, your microphone, your GPU, even your Bluetooth devices. And since 2016, they can talk directly to USB hardware through an API called WebUSB. Which raises an obvious question. If your browser can already talk to USB devices, why can't it just talk to your scanner? The answer involves 3 layers of increasingly weird engineering, and by the end, you'll understand why someone decided the best solution was to run an entire Linux distribution inside a browser tab. Let's start with what scanners actually need. Most consumer scanners from the 2000s expect to communicate using one of 2 standards, Twain on Windows or Sane on Linux. These aren't simple protocols. A scanner doesn't just send raw pixel data over USB. It needs initialization commands to calibrate the lamp, motor control signals to move the scan head at precise intervals, usually 300, 600, or 1,200 dots per inch, color correction lookups, and sometimes proprietary compression. A typical Epson or Canon scanner might exchange dozens of USB control transfers and bulk transfers just to scan a single page. And all of that complexity lives in the driver, a piece of kernel mode or user mode software that knows exactly how to speak that specific scanner's dialect of USB commands. Here's why modern operating systems won't load those drivers. First, driver signing. Windows 10 and 11 require all kernel mode drivers to be cryptographically signed by Microsoft. If the manufacturer went out of business or simply stopped paying for code signing certificates, the driver won't load, period. Second, architecture mismatches. Many old scanner drivers were compiled as 32-bit executables. macOS dropped 32-bit support entirely in 2019 with Catalina. Windows 11 on ARM won't run x86 drivers at all. Third, API changes. Linux kernel USB APIs have evolved. A driver compiled against kernel 2.6 won't work on kernel 6.x without recompilation, and good luck finding the source code for a scanner driver from 2004. The result, your hardware is fine, but the software bridge is gone. WebUSB was supposed to fix this. Introduced by Google in 2016 and now supported in Chrome, Edge, and Opera, WebUSB lets JavaScript code in a web page request permission to access a USB device and then send raw USB control, interrupt, and bulk transfers directly from the browser. It's the same low-level access that a native driver gets, just exposed through a JavaScript API. In theory, you could write a scanner driver in pure JavaScript. In practice, this works beautifully for simple devices like Arduino boards or firmware update tools, but scanners are a different beast. To write a JavaScript Sane driver for even a single Epson scanner model, you'd need to reverse engineer the USB protocol, implement color correction and calibration routines, and handle edge cases like jam detection and lamp warm-up timing. Now multiply that by 1,000 scanner models from 24 manufacturers. Nobody's doing that. So here's the trick. Instead of rewriting drivers, just run the original Linux drivers. Linux has Sane, the Scanner Access Now Easy project, which includes open-source drivers for roughly 3,000 scanner models. These drivers already exist, they're maintained, and they work. The problem is they expect to run in a Linux environment with kernel USB support. Solution: run Linux. Not in a virtual machine on your desktop. That defeats the portability goal, but in your browser. Projects like v86 and JS Linux use WebAssembly to emulate an x86 CPU and run a full Linux kernel and user space entirely in JavaScript. You can boot Alpine Linux, Arch, or Debian in a browser tab in under 10 seconds. It's absurdly slow for general computing. Emulated x86 runs at maybe 1/10 native speed, but for running a scanner driver that spends most of its time waiting for USB transfers, totally adequate. But now you have a new problem. Your Linux VM is running in a JavaScript sandbox. It has no access to real hardware. USB devices are outside the VM. So how do you connect the emulated Linux USB stack to the physical scanner plugged into your computer? This is where USB/IP comes in. USB/IP is a protocol originally designed for server environments, allowing USB devices on one machine to be accessed over a network by another machine. It works by encapsulating USB request and response packets inside TCP or UDP packets. A USB/IP server runs on the machine with the physical device, listens on a network port, and forwards USB traffic. A USB/IP client on another machine connects over the network and presents the remote device as if it were local. Normally, this runs over Ethernet. But here's the clever part. Instead of Ethernet, you bridge the USB/IP client in the Linux VM to a WebUSB connection running in the browser's JavaScript context. Let's walk through the whole stack. You open a web page. JavaScript requests WebUSB access. You grant permission for the scanner. The page loads a Linux VM using WebAssembly and boots it in under 10 seconds. Inside the VM, a USB/IP client daemon starts and connects to a virtual network interface. On the JavaScript side, a WebUSB to USB/IP bridge listens for USB/IP packets from the VM, translates them into WebUSB API calls, and forwards the responses back. The VM sees the scanner as a local USB device at, say, /dev/USB/LP0. You run scanimage from the sane command line tools. Sane sends a USB control transfer to initialize the scanner. That transfer gets wrapped in a USB/IP packet, sent to the JavaScript bridge, unwrapped into a WebUSB call, and delivered to the physical hardware. The scanner responds. The response flows back through the same path in reverse. The scan completes. You download a PNG. The entire operating system existed for 30 seconds just to execute a driver from 2005. The implications here go beyond rescuing old scanners. This architecture proves that the web platform is now capable of full hardware virtualization with real-time peripheral access. You could use the same technique for old MIDI controllers, legacy lab equipment with proprietary USB protocols, CNC machines, even vintage game controllers. Any device with a Linux driver can potentially be revived through this browser plus VM approach without installing native software. That matters for security-conscious environments where users can't install drivers, for educational settings with lockdown computers, and for archival projects trying to preserve access to obsolete hardware. It also completely inverts the traditional software stack. We used to run browsers inside operating systems. Now we're running operating systems inside browsers to access hardware. But there are trade-offs. This solution is technically brilliant and practically absurd. Booting an operating system to scan a document is like chartering a helicopter to cross the street. It works, but the overhead is comical. WebAssembly emulation burns CPU cycles and battery. USB/IP adds latency, typically 20 to 50 milliseconds per transfer, which is imperceptible for scanning, but would break real-time applications like audio interfaces. And browser sandbox restrictions mean you can't access USB hubs or composite devices easily. Still, for the specific problem of legacy scanners, the trade-off makes sense. You trade efficiency for universality. You trade performance for zero installation. And you keep 40 million pieces of hardware out of the landfill by making the software bridge immortal. As long as browsers support WebUSB and WebAssembly, and both are now web standards unlikely to disappear, these drivers will keep working, even if every operating system on Earth drops support. So that's how you revive a scanner from 2003 using a web browser, a virtual CPU, a network protocol designed for data centers, and a driver written for a kernel that's older than TikTok. It's over-engineered, beautifully unnecessary, and it works. If you want to see more stories about technology doing things it was never designed to do, subscribe. There's a lot more where this came from.